You're looking at the animation. You want to become like that. You bored of being 3D. You want to become 2D. But isn't that cool? You're generating your own image that you can run, and it looks very cool. And it took amazing 1 millisecond to generate. It became a little bit better to draw, but it can be more optimized. At the end, I'm getting this small, beautiful image. Hi, if you want to generate an image, create a minimap, for example, VFX, or to play a video, welcome to the tutorial. Today we're going to explore the editable image. First, before that, let's talk about the properties of the editable image. The maximal size is 1024 by 1024. If it's bigger, it's going to snap to that. In order to write the pixels in the editable image, remember that all pixels are located in only one table. And for each pixels there are 4 values, and it goes like RGB alpha, RGB alpha, and so on, so on, so on. Next one, you can apply editable image almost to everything that has an image, except of surface appearance. And then once I said like, the editable image is very, very fast. It is, but it's not. Let me explain you why. If you only write in the image, it will be insanely fast, like you can achieve 100 FPS, 120, but if you generate the image, it will be a lot of slow. To generate only one image on the big screen, right? Maximal size 1024 by 1024, it can take like up to a couple seconds. But how we can fight with it? How we can increase the speed of that? For that, I'm going to give you just a couple tips. Avoid something like mass.square root in your functions. Avoid calling function for each pixel. It will slow down the process. Okay, let's start with the tutorial. I'm going to turn off this annoying lamp. You're not going to see me very good, but it's going to burn my eyes. So today I'm going to switch the style a little bit how I make tutorials. Instead of just endlessly writing the functions, I prepared the whole place where you can go and look at the scripts and look what it do. So the link to that place will be in the description, and don't forget to enable the beta feature editable images, editable meshes. And at the end of this video there will be a small bonus for those people who want to compress videos and images. Here I prepared a lot of stands with different functions and a lot of the explanations. If you, for example, open a script, you can go to the stand, decal, and a script. You see how heavily commented it is. So again, link on the place in the description, and let's start with the video. Before we go into any stand, let me show you the possibility of the editable image. Of course you can do this like without editable image, but for tutorial we're going to do everything with it. For this video I created like a small character that you can run as him. As you see, it is animated and it looks very cool. First thing, how to create an editable image. So let's take a look at first 2 stands. So I'm going to open the scripts. Every script you can find in the decal and the script. First one is going to create an empty image. So you just use instance.new editable image, and like in the case of the editable mesh, if you parent this to the image object, it will override the image. So if you want to save every pixel of this Among Us, you have to use the asset service. But instead of putting image object inside of this create editable image async, you put the texture of the image or just a link, and then you parent this editable image to the image object. Let's take a look. Here's without asset service, I press, and Among Us has disappeared because editable image overwrites the existing image. And with this, I'm using the asset service. If I press, nothing happens because we saved the image. And in the course of this tutorial, we're going to create a drawing game, a small drawing game. For this, we need to explore some basic functions. Let's open this stand. So editable image has something like draw rectangle, draw circle, draw line. We put the position. In case of rectangle, we put the start position, and the color with transparency as well. So the next one is draw circle. You just put the position of the circle, radius of the circle, as well color and transparency. And the last one is draw line. It has position 1 and position, color and transparency as well. So I'm going to press this button. So it draw a circle, yellow circle, line, as you see 1 pixel line, and a rectangle. So let's start with our drawing game. For this we need a GUI. I already created a screen GUI here. We're going to create an image label for this because we need an object that has an image. And we're going to use the maximal size of the editable image, which is 1024. So I'm going to put the size of the image label here. As you see, it's totally gigantic, but let me put on a test. It is going to be 9020. So let us center that image, as well some adjustments. So first, let's create a script. In it, we're going to create an editable image with instance and parent it to the image object. And we're going to put the size of the editable image to 1024. Okay, that's going to override our image. Next, we need a mouse and a local player. To draw the mouse is enough, right? But we're going to define run service as well. Okay, next we're going to create the functions that are going to detect the mouse position on the canvas. For this we're going to use the absolute position of the object. Okay, with that, we first find the relative position to the canvas. After this, we multiply the scale by the editable image size. That's because the editable image size can be very different. And as well, we're going to floor this vector. So let's rewrite a little bit. Then we need to detect if we're pressing the button. And as well, let's do something with it. So in our case, we're going to draw a circle where we press. And with transparency 0, and now we need to connect this to the mouse click. Okay, and the thing is, we multiplied mouse relative position, but we need multiply mouse relative scale in order to get the position. Okay, and now we press run. And if you click, you spawn the black sphere on the mouse position. Yeah, but we want to draw with that. So let's use run service for this. We need to detect if we clicked or no, and then if we clicked, we're going to draw a circle. So let's create a variable. And let's record if we click the button or no. Okay, then we don't need it here. We're going to cut it with Ctrl X. Then we're going to connect it to render stepped event. It is run service. And let's connect another function when we release the button. In run service, we're going to pass our script with mouse position. We're going to get the mouse position and we're going to draw a circle. And then we need to check if we're pressing the button. Okay, and let's test the game. As you see, we draw a circle if we're holding the left mouse button, but for some cases it's not enough when we move the mouse too fast. We can of course use the FPS unlocker. Okay, with FPS unlocker a little bit better, but still not enough. And for other case, let's just draw a line if we hold the right mouse button. For that we're going to detect the same thing, and I'm going to change a couple of things. So if we press the right mouse button, we're going to save the position of the mouse and then update it each frame, like where it goes. Then if we release the button, we're going to draw a line from one position to another position. And again, if our mouse is too far away, we're going to snap that position back to our canvas. And as well, we're going to clear the variable mouse position. And yeah, of course, we need to disable our character because we cannot move the mouse. And for now, instead of disabling the character, let's just, instead of circles, we're going to draw the lines. So I'm going to use the button 1, and again, let's just take the 2. If I hold my left mouse button, we can draw a line from one place to another. Oh yeah, and let's fix a couple things like this one and this one. By the way, here index starts with 0, 0, not with 1, 1. It's not a regular Lua table, and to find out that, you can look in the scripts in the stands. I somewhere put that in the comments, so you can go and download that place. Okay, we got our small drawing game, but lines and circles, it's not enough. Let's take a look how we can draw pixels. For this, we're going to our next stand that will explain us how to write pixels. If I open the scripts, you're going to see something strange like DrawUtilities. But for now, let's just focus on how to write pixels. So to write pixels to the image, we can use editable image, like draw rectangle. We can draw rectangle with only one color from start to finish and with some transparency. It can be useful if we want to color the whole image at once. But if we want to draw something on that image or generate an image, we need another function. For that, we're going to use the function write pixels. Let me explain what it does. Here you put the start position, size position, the same thing as with the rectangle. So let me write the rectangle as well here. Let's look at the difference between these two. In draw rectangle, you put the start position, the end position, and the color with transparency. But what do we do with write pixels? To write pixels, you need a table of pixels. You can generate this table. So the size of the table should be width multiplied by height multiplied by 4. Let me explain you why. The whole table should contain like each pixel and each channel to that pixel. And you can write in the table RGB alpha, RGB alpha, and so on, so on, so on for each pixel. So let's create a simple function that will fill the image with particular color. Then we're going to create table and we're going to loop through each pixel and write the value in the table. Yeah, as well we're going to put the size of the editable image in that function. So basically we can do this in two ways. Maybe there's more, but let's explore the basic two. First one is just looping through amount of pixels, and we're going to insert the values R, G, B, and alpha. But if you want to be specific and generate for each index, that's going to be useful for generating. You're going to find the index of the pixel by this formula. Y multiplied by width plus X and multiplied by 4, because each pixel has 4 channels. And then we're going to get the index from 0 to amount of pixels multiplied by 4 minus 1. So we're going to increment this value by 1. This is going to be red value, green value, blue value, and alpha value. But remember, alpha is opposite of the transparency. We used to assume that transparency 0 is visible, but alpha 1 is visible. Alpha is basically 1 minus transparency. So with this, we're going to generate a table of pixels. Let me comment this for now. And then we're going to create a table. We're going to fill the image with red color, and it will be not transparent. Alpha equals 1. Yeah, and we forgot to return the table. For that instance, we're going to use only the first loop. Then I'm going to press button, and the whole editable image will be red. So that's how you write the pixel. But what the hell is the DrawUtilities? So to generate an image, it requires like a lot of experience. It's not beginner friendly. So for this tutorial, I prepared a small module called DrawUtilities. You can open it. It's located in the replicated storage. It is as well heavily commented, so you can read about like everything about circle, for example, how do I feel this, as you see the similar loop with a lot of explanation, so on, so on, so on. That topic is very hard to cover because to generate an image, it takes a lot of time. So your functions need to be as efficient as possible. These functions in DrawUtilities, I spent some time improving their performance, and we will talk about this later. So the analog to fill image, we can remove this one. So here we can create the image table as we did before. This function create image data, we put in the size X, we put in the size Y. You can change it in the function if you want to put just a normal size. And then we're going to put the color of red, green, blue, and alpha. And at the end, we're going to write the pixels. So if I press button, it's going to become brown. But if you put the table of the wrong size, or you will not put the table at all, it will give you an error like the table size should be X multiplied by Y multiplied by 4, as I described earlier. And here, let's look at the comparison. And there's another function, read pixels. I would not recommend to use this function very often because it is very slow. Like I benchmarked these two functions, write pixels and read pixels. So to write pixels, it takes like less than 1 millisecond. But to read pixels, it takes 12 milliseconds because it copies the table to you. But if you have the table and you can write the table, it will take not so much time. Yeah, and here you can read why the position starts with a 0. Okay, let's go to the next stand. Let's topic about the generating images. Let's open the script and look what's inside. Here I'm describing how to use DrawUtilities. First thing you need to do before you do anything with it, you need to create an empty image or some image of any kind. Then you put in the image table inside of that function, any function like of DrawUtilities. And that is going to draw on the table. Earlier I described how slow is the function read pixels. So that's why you have to create the table, then draw in the table, and then put the table inside of the image. If you will read the pixels each time you draw something, it will be very, very slow. In this instance, I'm drawing just a circle with a radius of 150. For that, I'm putting the image data, the size of the editable image, and I'm putting here the position where I will draw the circle, and as well RGB alpha value at the end. I have as well the function write image. So that's basically the analog to the function write pixels, but you don't have to put the vector 0 and the editable image size. You just put in the editable image and the image you want to write. But that image should be the size of the editable image. Okay, let's clear this. Yeah, and here as well you can see the function that generates the circle. You can find that as well in the DrawUtilities. For that you go into the replicated storage and look right here. So if I press button, it's going to generate a circle perfectly in the middle. So let's go to the next stand. It's called functions of DrawUtilities, and we're going to benchmark them a little bit. So let's take a look at the script. Here I'm drawing the line with thickness, like different sizes, and I'm benchmarking it. The benchmark code is here, so I'm recording the start time, recording the end time, and I'm just printing the difference, multiplied by 1000 to see how much milliseconds it took. So here as well, you create the empty image to draw something on it. Draw line with thickness has like a lot of arguments, but if you go to the DrawUtilities, you will find the explanation almost to every argument. So here you will see the image data, editable image size as well. Then I'm going to say the 0.1, 0.2. Then I'm going to put the thickness. After this, you will encounter a couple more parameters. For example, there will be density and the quality, and as well another parameter called rounding. So here I benchmarked almost every possible line. Of course, you can benchmark your own things. The code you can find in this comment. So here I'm benchmarking 50 pixel thick line with round edges, quality 1, density 1, without rounding with quality 0.5, density 0.5, then the line with thickness of 25 with round edges, quality 1, density 1, and the very thin line with 2 pixels but on full quality and density. So let's press the button and look at the results. First one is a line of 50 pixels with round edges, quality 1 and density 1. It took 17 milliseconds to generate. So the next one is a thickness 50 but without round edges. You see that round edges took like 7 milliseconds to generate. That's because I'm using the square root to generate this round edge, and you see how expensive it is. The next one, I lowered the quality on half and the density on half as well, and it took amazing 1 millisecond to generate this. But as you see, this line is only dots. Maybe you will find the use of that, maybe not. Maybe you will always put the quality and density on 1. The next one is line thickness of 25 pixels. It took 5 milliseconds to generate with quality density on 1, round edges, so on, so on, so on. And the smallest line, 2 pixels with quality on 1, density 1, took 1 millisecond to generate. That is very fast. Okay, let's take a look at another function of the DrawUtilities. Maybe you will find it interesting. So let me open this, and here you see the function draw triangle, but it's draw triangle slow because I don't have more optimized function. It didn't work. And here I'm drawing the normal triangle as well, empty image. I'm putting the first point, second point, and the third point. I'm putting the red, green, blue, and alpha. Only draw line with thickness has 2 parameters like quality and density. All the functions don't. So here as well, I'm benchmarking this triangle to let you see how long does it take to generate something big. Let me press the button and let's take a look at the results. So we drew a triangle from this point, and this point, and it took 300 milliseconds to generate. If you write to editable image, it will be insanely fast, but to generate the image, it will be insanely slow. Okay, what we can do with this thing right now? We can improve a little bit our drawing game. So let's go to the script. So let's remove this line thing. We don't need the line for now. Here I'm going to require the DrawUtilities. And now let's change this a little bit, remove this one and uncomment this one. Then we're going to uncomment as well our run service loop. And here I'm going to save the mouse position. So first I'm going to generate the empty image. And then if we have first mouse position, so start where we press the button, we're going to write the line from this previous position to the new one. Okay, and now let's take a look at this. So I'm going to generate the line with thickness of 15 and I'm going to draw. Yeah, as you see, it became a little bit better to draw, but it can be more optimized. So if we're doing some very rapid movements, right, the Roblox is going to pick up this thing, yeah, and we can draw the whole image. Now let's go to another stand and let's take a look how did I make the animation for our character. So our character has a sprite sheet of animations. For this, I'm going to split this sprite sheet on the smaller sprites with particular size. The next, we will encounter the problem. As you see, the decal, we're using the decal right now, and it doesn't like the very small images. So we're going to upscale this image. So both these functions you can find in the DrawUtilities as well. So let's open the script and take a look. How does it work? First, I'm creating the editable image, empty image as well. I'm using the sprite sheet URL. I'm creating the editable image from the sprite sheet. Then I'm going to define the sprite size. This will be 24 by 24 pixels. The sprites I'm going to get by the function split. It's going to return us all the images of this particular size, so 24 by 24. But if you have the image like with 1 pixel bigger or something like that, it's going going to give you this 1 pixel image. And if you write that 1 pixel image inside of the editable image, yeah, it can give you an error because size is not proper. So what do I do next? I'm destroying the sprite sheet because I don't need it. I already got data. Then I'm scaling this sprite size by 10 times and I'm looping through each sprite and I'm scaling it. If I'm scaling the image, it doesn't override the original image. It gives you the new scaled image. So I'm going to rewrite the existing image with new scaled image. I'm going to use mode linear. I don't have bilinear for now. I'm changing the editable image size to the scaled sprite size. Then I have a grid. We have a lot of animations. It is by 7. Let me open the script once again. Then I'm going to create a function that takes the index of that image because we have only 1D array. We want to get the image in 2D array. So here I'm multiplying y by width and I'm adding the x. And at the end, I'm going to add the 1 because Roblox table starts with 1. Then I have some table of the animation called run. It is row 1. So we're starting with 0, 0 in that case. So run animation will be row 1 and it is 6 frames. Let's open the script. Then I have my FPS counter. I'm waiting 1 divided by FPS time. Then you're going to need the iterator variable. That's going to loop through each animation frame and set new one. Then I'm going to mod this to the amount of frames that it's going to be from 0, 1, 2, 3, 4, 5, 5. The amount of frames is 6. It's going to return to 0. So it's going to be the first frame. Then I'm going to just write the sprite inside of the editable image. I basically don't need this, but let it be. For now, let me press run. As you see, it processed our image and it displayed the sprite 7 times per second. Yeah, so that's how our animations look. As you see, my character got a little bit more animations. You can look at the script of the character inside of the starter layer. Then you go to the character script and animator. Here you will maybe find something useful. So let's go to another stand. That is another great example how to generate an image. For example, let us open the script inside of it. I'm generating the RGB image like you see when you pick in the color. Let me show you an example. If I press this color wheel, you will see this rainbow image where you can pick the color. Of course, you can make this image by yourself. You don't need to go to Google and search for it because you can generate it. Here I'm using the most useful function I've ever created. Then I'm looping through each pixel. Here the loop you saw earlier. Then I'm using the X and Y values to get the color of the image in that particular pixel. So for example, here you see from here to here, I'm going to use the color space HSV, that is hue saturation value. You can read about this in the internet or here somewhere in the comments. You can find the link. Then I'm going to use the faster function of converting HSV to RGB. So I'm converting the X from 0 to size X minus 1 to range from 0 to 1. And the same thing for Y, but I'm converting to the range from 1 to 0 that will be inversed. So 0 here will be 1 here. You can read about this function here in the description. Then I'm converting HSV to RGB and I'm writing as well RGB and fully visible. That is heavily commented. Of course, you can just take a look at this. So let me press a button. If I press the button, it takes some time, but at the end, I'm getting this small, beautiful image. Yeah, of course, you can find it in the internet and you can do like a lot of analogs of the editable image. But isn't that cool? You're generating your own image. That thing taking the images from other person. Generate it. If you have a good algorithm, you can generate a cat. Okay, let's take a look at the other stand. The other stand is very special because it's a bonus. Recently, I was curious about, can I put like an image inside of Roblox without ever uploading it? For example, to compress this image, to convert it into string, put it in Roblox, not the image itself, I'm putting the string, just the normal text, and then reverse this text back to the image. So I started my project on C++. Right now, let me show you. Of course, the source code to that project you can find in the description on GitHub, and of course, you can find the link to that exe file. So let me show you how it works. The first, you will have just exe file, DLL, this thing, I don't know whether I need to put this, and the core. After you run in this exe file, it will create images and out 2 folders. Then you put every image you want to convert to string, like 2 images. In this case, this will be YouTube icon, subscribe, of the format WebP. It does support it. If I run this, I press in enter and it compiled my image. 80 kilobytes, a great size. If I open this image, you will see you can read this image and you can like select the whole image and copy. Let me open the normal image. For example, I'm going to open this with Notepad. You will see a bunch of different symbols, very scary ones that you always look at it and what the hell is this? But the thing is, you cannot copy like half of them, not the half, but a little bit less. There's a symbols that you cannot copy and that's the problem because you will lose the data from the that image and you will not be able to restore. That's why you will see the image like this written in a fully readable text. Of course, it takes a little bit more data and a little bit more computation to convert this to the readable text. So I'm going to take the text, I'm going to that stand, and I put this image inside of this module script image. As you see, I put this 80 kilobyte string inside of one single module script. Let me close it. Let's open the script of the sprite and let's take a look how we can restore the image from the string. Of course, you can find more description on the GitHub, link in the description. So now when you require the module of the image, it's going to return as a text. It's going to be image 64 and then we need to decode it. For this, you can use a couple modules that you will find here. Of course, you can copy them, bring it to your own place. From this, zlib is open library and everything else is written by me. So here, first, to recover the image, I'm going to create editable image first. Then I'm going to put this image back to the normal string like it was from this base64. Then I'm going to put this string inside of the buffer, so convert buffer to string. After this, I'm going to decompress this buffer. It took a lot of steps because I had to put like the data from C++ to Lua and from Lua back to C++. Yeah, it was a little bit stressful. Then you're going to decompress the buffer with buffer utilities decompress. It's going to return the buffer. Then you have to convert the buffer back to the string. So read string from 0 to length of buffer. Then you're going to again convert this from the base 64 and then you're going to create a buffer again with the string you decoded. And there's one last step, almost one last step. You need to decode the image. I used encoding of Qoi. It is recent algorithm of encoding images. It is basically very fast to decode, encode, but you will achieve the size of the PNG. And after I'm encoding in Qoi, I'm compressing it with zlib. It is very interesting one. You like cutting the 70% of that image size. But if I convert to this base, it's going to again restore some size, but it's not as big as original image. Then I'm going to decode this buffer. I need to put buffer here. I'm going to get the data. So that's again buffer. I'm going to get the width, height, channels, and color space. Channels can be 3 or 4. That depends on original image, but Qoi will always return 4 channels because it will be a little bit easier for you to write in the editable image. So you don't need to like convert it back to the color 4 or something like that. But it just gives you some information at how much channels does that image have. Okay, then I'm going to create the image table. So this is the buffer and we cannot write buffer inside of the editable image. So I'm going to use this function. I'm going to convert buffer to table and then I'm going to put parameter here to true because I'm storing the pixels from 0 to 255. So as well, encounter on that one, if you want to like encode this image, convert this in range from 0 to 255 and let it be integers and floor these values. So I'm going to put this true, that's going to convert it back to from 0 to 1. It's going to convert to the normal range that editable image can read. Then I'm going just to write this image to the editable image. So I'm going to press run and I'm going to test this stand. Okay, let's press this button and let's see what happens. Subscribe! Of course you can do this. The image encourages you. That is basically, I think, the foundation of the new project I'm working on. About video compression. You will be able to compress the whole video. Put it in Roblox. Maybe you can do something small with normal image labels, but it's only a string and you put in string to Roblox and you playing this as a video. Isn't that impressive? I'm right now learning a couple other compression algorithms, but that will be a little bit later when I release the newer version that will be able to compress videos and maybe other stuff. Then you will be able to put this in Roblox. Yeah, the Roblox prices are incredible. 2,000 Robux per video and 3 uploads per month. Oh my god, who's gonna pay? So let me explain how to use this exe file. One exe file is not enough. You need to install one C++ library called OpenCV. So the link to that library will be as well in the description. It is going to look like this. Then you go get started. So then you're going to press on C++ this link. Make sure that you're installing 490. Maybe you watch this in the far future where we have flying cars, where we superheroes flying on our costumes to work. So just make sure that you're installing 4.9.0. You're going to need this exe file. Then you need to install this library. I installed this library on the disk D. Here it is. You open this library. You go to build x64 vc16 and then you're going to open the bin folder. Then you copy the path to that bin folder. That is very important. Then you right click on the Windows button. You go to System, Advanced System Settings. Need to open this thing, Advanced System Settings. You open Environmental Variables. You double click on Path. After this, you press in New and you put in the link of the bin file you copied here. That is the same like path, as you see. OpenCV, build x64, VC and bin. So you put it here, you press OK, OK, and then you can use this program. After this, you just put everything you want to compress inside of the images and you press enter in this exe program. If you got like a lot of images, you need to wait a little bit until it starts to save in the images. If it's done with image, it's going to save that in the file that is going to be here. You will find it here in the text file. It's going to have the same name. So, and for today, that's it. Thank you for watching and hope you're doing great. Bye bye.